Okay, on this first part, we're going to go through graphs. By the time we get done with this chapter, you'll be able to do all 6 trig graphs without a graphing calculator. This is on graphs of sine and cosine. And notice in the title, it's sine and cosine functions. These are all 6 trig functions. That means vertically, if you do your vertical line test on the graph, it will only intersect the graph in one point, up and down. Okay. Before I go through the actual graphs, I want to go through what they call line values. Okay, and this is kind of a way to help you graph, especially sine and cosine. Okay, they're called line values. You have seen them in geometry before. In geometry, it would have looked like this, and you would have called it a ray. If you go into physics, okay, and if we have enough time in trig, we'll get to it. In physics, they would call it a vector. Okay, line values, rays, vectors, different names for the same thing. The critical part about this is that we are going to be in a unit circle. A unit circle. And that means anytime you see a unit circle, that means your radius is equal to 1. It might be 1 inch, might be 1 centimeter, what might be 1 foot, might be 1 mile, but it's equal to 1. The radius is equal to 1. Okay? Okay. For about half your paper, draw a big coordinate axis with a big circle. Okay, and that circle has a radius equal to 1. Okay, now I want an angle that is not 45 degrees. I want it less than 45 degrees. Okay, so from here, and extend that terminal vector out. Okay. From the point where it crosses the circle, drop a perpendicular down to the x-axis. That perpendicular always comes down to the x-axis. Okay. Now this is the reference angle theta inside. If you look at that triangle, in that triangle, this is the opposite, and this is the hypotenuse. But what's this hypotenuse? 1. It's 1 because that's the radius of the circle, right? So if I looked at the definition for sine, sine of theta is opposite over hypotenuse. The opposite is this vector or line value, and the hypotenuse is 1. So label this is sine of theta. That line value represents sine. In that same triangle, this one is the adjacent side over the hypotenuse, but the hypotenuse is 1. So this, and put an arrowhead here, this represents cosine of theta. And it's positive in quadrant 1 because you're going to the right. The sine was positive because you're going up. Okay? Okay, from the point where the circle crosses the x-axis here, okay, draw another line value. Okay, now look at the large triangle. Look at this triangle. In that triangle, and you're still looking at this as the reference angle, this would be the opposite over the adjacent, but the adjacent side is the radius, which is 1. So this is tangent of theta. In that same triangle, This would be the hypotenuse, okay, over the adjacent, but the adjacent is 1. What's hypotenuse over adjacent? Secant. Okay, put an arrowhead here. This is secant of theta. Okay. And put a little note. Secant and tangent arrowheads always touch. The secant and tangent arrowheads will always touch. Okay. Okay, now up here where the circle crosses the y-axis, okay, go parallel to the x-axis and extend it out to meet that terminal vector. Try to make these two parallel. Okay. Now this is a right angle. Now we're looking at this triangle right here, this larger triangle right here. If this line is parallel to this line cut by a transversal, this angle and this angle are equal. Why? Two parallel lines cut by a transversal. Why is this angle equal to this angle? Alternate interior angles are equal. So now we're looking at this larger triangle and we're looking at this as theta. In terms of that angle, this would be the adjacent side to that angle. This would be the opposite. You don't have to label those. I'm just trying to show you. I shouldn't have it on there. This is opposite, or the adjacent over the opposite, but the opposite's 1. So this adjacent is cotangent. And there should be an arrowhead right here. Okay. In terms of that same angle, this theta, this would be the hypotenuse over, this is the opposite, hypotenuse over the opposite. What's hypotenuse over opposite? Cosecant. So this is cosecant of theta. And you need another arrowhead here. Okay. Now, those are all positive, and this is the drawing for quadrant 1 for the line values. Those are all positive because they're all going up or they're going to the right. You're going to have to recreate this. When I grade this, I'm looking for 6 arrowheads. Out of that first triangle, you will always get sine and cosine out of the first triangle. Out of the second triangle, you'll always get tangent and secant. And out of the third triangle, you'll always get cotangent and cosecant. And notice they all go from the origin. Okay? Okay, that's quadrant 1. Let's do quadrant 2. Same thing, do another about half. This may take a couple of pages. Do a big enough picture that you can see it. Go about half a page. Okay, now we're going to do quadrant 2. Okay? The reason I say don't make your angle 45 degrees, because then you've got too many arrowheads on top of each other. Okay, so we're going to start here. Okay, we're going to go over into this quadrant, extend that out. Okay, and we're going to look at quadrant 2. Okay. From the point where it crosses the circle, okay, drop a perpendicular, and this is our reference angle theta inside. If we do sine opposite, this would be the opposite. Okay, opposite over hypotenuse, but the hypotenuse is the radius of the circle, so it's 1. So label this. This is sine. That that blue vector is sine of theta. Cosine is adjacent, adjacent to this theta, adjacent would go, now notice it does not go all the way out to the end of the circle. It stops in the triangle, stops right there, and it's going to the left, so cosine is negative. You make sure you have two arrowheads so far. Okay, now tangent, everybody look up here for a minute. Tangent touches here in all four quadrants. Okay, so what you have to do is extend this terminal vector. It should be a straight line. Extend that in the opposite direction. So tangent. Now we're looking at this as our theta. Why are those two thetas equal to each other? For me to have two angles equal to each other. What kind of angles are those? Starts with a V. Vertical. Vertical angles are equal. Okay. All your geometry's coming back. So vertical angles are equal to each other. Okay, so tangent starts at this and goes down to meet that terminal vector. Tangent is opposite over the adjacent, but our adjacent is the radius of the circle. And it's going down, so tangent is negative. If you look at that same triangle and do secant. Secant is the hypotenuse. Notice from 0 to right where it's going to touch the arrowhead for, okay? Secant is hypotenuse over the adjacent, but the adjacent is 1. Okay, now, how can you tell if it's positive or negative? If the terminal vector, okay, the terminal vector is going this way. Your secant's going this way. They are in the opposite direction. Another way to say it, if it's on the dashed line, it's negative. Okay, so this would be negative secant of theta. Okay. Everybody look up here for a minute. On cotangent, cotangent touches up here in all four quadrants. It will always start at this point. Okay, so it's got to go to the left to meet that terminal vector. You need an arrowhead or a vector because it is a line value. Okay, and now we're using this as our theta because alternate interior angles. So we're looking at this big triangle. We're looking at this triangle right here. Cotangent is going to the left, so it's negative. And cotangent, remember, is adjacent. Okay, it's the adjacent over the opposite, but the opposite is 1. Okay, and then the last one is cosecant. It always goes to the origin. And it's cosecant of theta. Okay, and there's an arrowhead up here. So those two should touch. And it's positive because it's in the same direction as the terminal vector. In quadrant 2, what should be positive? Sine and cosecant. All the rest of them should be negative, so check your drawing. Sine and cosecant are positive. All the rest of them are negative. Do you have 6 arrowheads? Okay. Everybody okay with that one? Okay, now do quadrant 3. Okay, so now we're going to look at this quadrant. So draw an angle. You're going to start here in standard position, go over into quadrant 3. Do not do a 45-degree angle. Do like about a 30. Extend that out. So now this is our reference angle theta. From the point where it crosses the circle, drop a perpendicular back to the x-axis. Sine is opposite over the hypotenuse, but that hypotenuse is 1. So this is sine, and it's going down. So it's sine of theta. Down, negative. Cosine is adjacent.
Miss Elliott.
Yes.
Do you have any for lunch?
Nope.
Thank you.
Cosine. Cosine negative, because we're going to the left. Tangent touches here in all four quadrants. So you got to extend this up in the opposite direction. So tangent's going to be right here. Now this is our theta. Tangent is opposite over adjacent. But our adjacent is 1, so this is tangent. And it's positive because it's going up, and this also represents, this whole drawing represents quadrant 3. Okay? Even though that shows up in quadrant 1, but it's quadrant 3 that we're drawing. Tangent and secant arrowheads always touch. So from this point, from the origin to here. Now, don't do this. This is an error. Sometimes people do this. They put the arrowhead on the brace. No. The arrowhead actually goes on the line value. Okay? So this would be secant, and it's in the opposite direction, or it's on the dash part, so it's negative. Cotangent touches up here in all four quadrants, so it's got to go to the right. Draw it parallel to the x-axis. Now we're looking at this as our theta, alternate interior angles. It's going to the right, so it's positive. Make sure you have an arrowhead on there. Cotangent, I didn't say this, I didn't write it down. Cotangent and cosecant arrowheads always touch also. Okay. Put another arrowhead on that line. Okay. And this is cosecant. The terminal ray is coming down here. Cosecant is coming this way. It's on the dash, so it's negative. Okay. So now check. In quadrant 3, what should be positive? Yep, those two should be positive. Everything else should be negative. Do you have 6 arrowheads? Everything else is negative. Yep. Okay, last quadrant. Quadrant 4. Remember, if you miss any of this, you can go back through it on iTunes also. Okay, so now we're going to do quadrant 4. Okay, start in standard position. You're going to go around into quadrant 4. Don't make it 45 degrees. Okay. And there's our terminal vector. So this is our theta. From the point where it crosses the circle, okay, from this point, drop a perpendicular back to the x-axis. Sine is opposite over the hypotenuse, but the hypotenuse is 1. So this represents sine of theta. And we're going down to meet that terminal. So it should be negative. Can you see that? Negative sine of theta. What should be positive in quadrant 4? Cosine. Okay, and cosine is the adjacent. And it should stop right at that triangle. It does not go out to the end of the circle. And it's positive because it's going to the right. Okay? Tangent starts at this point, and it's got to go down. It's parallel to sine, and it's negative. So that's negative tangent of theta. Make sure sine's negative on that too. Okay? And then from the origin to here, I'm going to pick a different. Okay? And this is secant of theta, and it's positive. Cosine and secant ought to be positive. It's in the same direction as the terminal vector. Okay, now you got to go in the opposite direction. Dash it. Oop, not very straight. Kind of crooked. Okay. Cotangent touches up here in all four quadrants and goes left or right. So it's got to go to the left. Try to go parallel to the x-axis. We're going to the left, so it's negative. Cotangent of theta. Make sure you have an arrowhead on it. Okay, and then touching cotangent and cosecant arrowheads always touch. It goes back to the origin. So cosecant of theta, it's negative, and make sure you have another arrowhead. They should be touching. Okay, so I should have cosine, and secant are positive. All the rest of them are negative. And you should have 6 arrowheads. Okay. Okay on that one? Okay, now, how do you use that to help you draw the graph for sine and cosine? Okay, so let me take you through that. Draw one little circle out here. Okay, and out at the side, standard labels when we start drawing these graphs. Okay, and we're going to draw, first one we're going to do is y equals the sine. And it's sine of theta. On the calculator, it'll be y equals sine of x. Standard labels. Okay, on the x, I want you to label pi over 2, pi, 3 pi over 2, and 2 pi. It's every half pi. Negative pi over 2, negative pi, negative 3 pi over 2, and then there'd be a negative 2 pi. Okay. And then on the y, go up 1 and down 1. So it's pi over 2, pi, 3 pi over 2. So it's just like 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. It's every half pi. Okay? Okay, now, if you look, and all I want to look at is the sine line value, the sine vector. Okay? This one was sine right here. Okay? If I rotate the terminal vector down, what happens to this sine vector? Gets shorter, doesn't it? Gets smaller. Until, if I go all the way down to 0, it's right here. Okay, so on the graph, right at the origin, put a point. If I extend this terminal vector up, the sine line value gets longer. All I'm looking at, that red, okay, it gets longer till at 90 degrees. 90 degrees is the same as pi over 2 radians. It would be right here. It's still inside the circle, but what's the radius of the circle? Still a unit circle, radius 1. So at pi over 2, it's 1. So what we actually did without a calculator is that sine value got longer, longer, longer. Okay. When I come over into this quadrant, I'm not going to show them all, but it's going to get shorter. Okay, it gets shorter. What's it going to be when it gets down to 180? It's going to be down to here, right? So what that sine is actually going from 0 up to 1, and then it's going less than 1, less than 1, less than 1. It's getting down to 0. So it's going like this. It's going smaller, 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 smaller. So at pi, this pi or 180, pi or 180 degrees, it's going to be back to 0. When I come down in this quadrant, okay, all of a sudden I start going negative. Okay, it's going to go negative till at 3 pi over 2. This is 3 pi over 2 or 270. It's going to be right here. So it's going to go down like this at 270 or 3 pi over 2. And then at 2 pi, it's going to come back up to here. So here's the main 5 points, the 5 points that you need for the sine. And then you basically have a graph that looks like this. The sine graph. It'll be a smooth curve. That should go through. Okay. And then it will repeat. Notice it stays in the envelope of 1 and negative 1. Okay, and if it starts here at 0 and it's going up, When is it at 0 and going up again? Right over here at 2 pi. It would just continue on. Okay? So that's how you can do the sine graph without a calculator. I didn't use a calculator at all. Okay? And if you remember those 5 points, okay? Now, is the sine graph even or odd? Can you reflect it about the y-axis and get the same graph on top? Can I fold this part over and get the same graph? No, because it'd be up here, right? Can I rotate that graph 180 degrees about the origin? Yep. So the sine graph is odd. It's an odd. You can rotate it 180 degrees. Okay. And if you just remember odd and origin, you can rotate it 180 degrees about the origin. Okay. Okay. See what we can get on the next one. Oh, one other thing on this. If I look at this, if it's odd, if I say pick an x value here, and this x value is opposites, what about their y values? Opposites. So if I gave you, on the homework, if I gave you the sine of 57 degrees, okay, on your calculator, make sure you're in degrees. Let's go sine of 57 degrees as an example. Sine of 57 is 0.8387. They would give you that in the book. And then they would say, what's the sine of negative 57? Do you need to punch it in on the calculator? No. If the x values are opposites, the y values are opposites. That's what they're trying to get you to do on the homework. Don't use a calculator. Okay? If the x values are opposites, these x values are opposites, the y values are opposites. So all they're asking for is what's that sign, positive or negative. Okay? Okay, let's look at cosine. Draw a little circle. Every pi over 2, so pi over 2, pi, 3 pi over 2, and 2 pi. And then it'd go negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, and if we looked at cosine, okay, cosine is this one. Okay, it's this line value right here. So if I rotate that terminal vector down, cosine is actually all the way out. So cosine starts up at 1. Okay, as I come up, this cosine is just going to get shorter, shorter, okay, till at pi over 2, it's back to the origin. So it's doing this. Okay, at pi over 2, okay, it's back to 0. Okay, as soon as I come over here, it's going to the left, it's going negative. So the cosine is just going from 1 to 0, back out. Okay, so it's going down this way to negative 1. It'll come back up. 3 pi over 2, it's back to 0. Okay, so it's going to go like this. Okay, and the main points are at 1. At pi over 2, it's 0. Pi is negative 1. 3 pi over 2, it's back to 1. Okay, and then it repeats. Okay. Now, is this one even or odd? This one is even. You can rotate it about the, or not rotate it, you can reflect it about the y-axis. So this one is even. So, if I pick an x value here and an x value here, what about their y values? Ought to be the same, right? So if I said cosine of, let's do like cosine of 12 degrees. So if I did cosine of 12 degrees as an example, 0.9781. So what's the cosine of negative 12 degrees? Ought to be the same. Okay, if the x values are, if you look at this, if the x values are opposites, the y values are the same on cosine. No matter where you pick it, x values are opposites, y values are the same. Okay, so they're not trying to get you to use the calculator. Okay, I think we're about done. Okay. Okay, so take that much